Okay, so today we're going to be working on solving exponential equations without the common base option. And so let me remind you of the common base option. If I were to give you the problem 2 to the x power equals 8, you have already the capability of solving this problem because you can write 8 as a base 2. 2 to the x equals 2 to the third, therefore x equals 3. You have that skill. Okay, you also have skills to solve all kinds of equations. You can solve linear equations, quadratic, cubic, you can solve it all. Today we're going to be solving exponential equations where we can't create a common base, so we have to rely on writing them as logarithms and using our log properties so that we can find the correct answer. But I'm going to tell you this. You really don't need any skills above being able to solve an equation like this or like that. That's as difficult as this gets. Here you know you've got to put your x's on the same side, right? Linear. With the quadratic, oh, let me make that equal 0. You factor. X times x minus 1 equals 0. Set them both equal to 0. You find your solution. So this is as difficult as the problems get today. You will be using these basic solving equations skills. Okay? So first I would like for you to remember a really important log property that we have not used in practice yet, and it's this one. It's log property 8 that says if I have the log base b, I'm just going to go base 10, okay, of m, and it is equal to the log of n. If the logs of two numbers, m and n, are equal to each other, the logs are equal to each other, then the numbers are equal to each other. We haven't used this property yet, but we will use it a lot today. But we won't be using it in its original form. We will be using its converse form. So conversely, I should logically be able to say if some number m is equal to some number n, then the log of m will be equal to the log of n. It's just the reverse statement. And I think logically it makes a lot of sense. I do want to mention that we can also, instead of using the common log, I tend to use the natural log, and that's because I'm lazy. It's one less letter to write down. ln has 2 letters, log has 3. Yes? They'll get you to the exact same place, and so I tend to use the natural log. But it doesn't matter. You can use the regular common log if you want. So this rule right here in this form is the one that we'll be using to help us solve these problems. So we're starting off with the problem 3 to the x equals 5. And it's your job to solve for x. Now, if you're thinking logically, we know 3 to the first power is 3, and 3 squared equals 9, right? So 3 to the 1 point something equals 5. And I don't want to sit here and try to guess and check until I figure it out. I just like to be able to solve this problem. So what I'm going to do is I'm going to convert this to a logarithmic equation so that I can get this x powered down so that I can solve for it. So I'm going to take, if two numbers are equal to each other, do you agree these two numbers are equal to each other? Says so. Then I can say that the natural log of 3 to the x is equal to the natural log of 5. I did the same thing to both sides of the equation, and using the natural log will allow me to pull that x down, power it down, so that I can solve the equation. So I would call that property 8. If two numbers are equal, then their logs of those numbers are equal. Okay? And then my job is always to solve for x, so I need to get it out of this position up here in the exponential. So I'm going to use property 7 that says the log of a power is equal to the power times the log. You following me? I'm not hearing you. Okay, and that's property 7. You'll remember we practiced that. And you don't have to write the properties down or not. I'm just, if you don't want to, I'm just doing that. Okay, so I would like to isolate x. So if you're not seeing this, my suggestion is this. Pull the natural log out of the statement and come over here and come up with a plan how you're going to solve this. So this is pretty much similar to saying 3 times x equals 5. I'm going to solve, what's my plan for solving for x here? Divide by 3. So over here, I'm going to divide by the natural log of 3. And I'm going to get x is equal to the natural log of 5 divided by the natural log of 3. Now, of course, I can't do that in my head, but my calculator can calculate that answer for me. Now, what I did there is I used the division property of equality. I divided same number, both sides of the equation. Now I'm just going to, that's that step right there, plug it into the calculator. So x is approximately equal to, we're approximating, it's a log. Typically we'll go ahead and round to 4 decimal places. I'm getting the answer, 1.4650. Okay. And we call that substitution because all I did was substituted the natural log of 5 divided by the natural log of 3 with its equivalent value. Okay. All right. So now I want to know if I'm right. So I'm going to plug this information in. It's my check. I am requiring you to do this for your homework. So we're going to plug in for the x power here, 1.4650. And we're going to see what it equals. So if you could do that for me, check it. It's 5.0001. Ah, close enough. Why is it close enough? Because it's rounded to the nearest 10,000. We'd have to plug in the exact answer to make it equal exactly 5. And P.S., you could do that with this calculator. You can do 3 and then do your caret and then press second function negative and it'll plug the exact answer in and it will say exactly 5. So if you want to plug your answer in, you just use second negative and it will plug in the answer. Okay, so now I know that's correct. And all I did was use my basic solving skills for an equation. But I also used my log property so I could get that x that was in the exponential position pulled down, powered down, so that I could isolate it. Okay, I do want to mention one other thing before we go to the next problem. I'm going to erase this, and that's this. Be careful. Okay. The log of 5 over the log of 3 is not the quotient of a log. It's the quotient of 2 logs. 2 logs. So it means the log of 5 divided by the log of 3. It is not the condensed log of 5 over 3. They're different. See? Different. This one means what? The log of 5 minus the log of 3. Okay, so we're not using the log of a quotient here. We're doing the quotient of 2 logs. So just be really careful. I know we've just started working with logs and it's easy to confuse these things. 2 logs, separate, do exactly what it says. 1 log condensed. When we solve log equations, we'll be using the condensing one more, okay? So be careful there. All right, here we go with the next problem. So we're going to solve 6 to the x minus 3 equals 2 to the x. Now we have x on both sides of the equation. And my first question to you is, can I write 6 as a base 2? Can I write 6 is equal to 2 to some power? No. Okay, so we can't use the common base. So that means we're going to have to use the common log, or take the log of both of them. This time I'm going to use the common log instead of the natural log. It doesn't matter, and I want you to see that it doesn't matter. So this time I'll take the log instead of the natural log of both sides. It doesn't matter. If you want to continue with natural log because you're feeling lazy, go for it. Okay, true statement. If two numbers are equal, then the logs of those numbers are equal. That's property 8. Then my job is to get the x's isolated. So I need to bring them down out of their lofty positions. So this is the quantity x minus 3. You need to keep it a quantity because it's a single exponent. It's just got an unknown part times the log of 6. So we're powering down and powering down. X times the log of 2. That's property 7. That says the log of a power equals the power times the log. And we did that on both sides of the equation there. All right, so again, so that I have a plan, I want you to know that you have the ability to do this. I'm going to remove the word log so that I can develop a plan. So, and if you're okay, I'll put the 6 in front. So 6 times x minus 3 equals 2x. I'm just rearranging it in the proper order if I were to solve this. What would you do to solve for x? You would distribute, right? You do 6x minus 18 equals 2x, and then your next plan would be subtract the 6x, put it over here with this x, right? You have negative 18 equals 2x minus 6x, and of course you would put those together and say negative 4x. It's not going to happen over here because it won't be like, but, okay? So you know what, you have a plan. So here's what I'm going to do. I would like to get that x. I'm trying to solve for x, but this x is locked up. It's grouped with this 3. So I'm going to pull it out of that grouping. So x times log of 6 minus 3 times log of 6 equals x times log of 2. That's a distributive property. Okay, so I did that. Now, do you remember what I did next? Well, I put this over there, right? But could I also just do this? Put the x on that side and put the 3 log on that side? Are you okay with that? Just rearranging them so the x's are on the same side of the equation. So that would be x times log of 6. You say I subtract this x log of 2 to move it over here? Yes? So minus x times log of 2 equals. And what would I do to move this negative 3 log of 6 to the other side? Add 3 log of 6. So they're switching sides, and they're switching sides. So they're changing signs. And what I'm doing there is using the addition and subtraction properties of equality so that I can get my x's on the same side and move the log that doesn't have an x to the other side. So logs that do have x on one side, log that doesn't have x on the other side. And that's supposed to have a 6 on it. There we go. Okay, so my question to you is, can I combine these? Are they like logs? They're not like logs. Okay, so what could I do to isolate the x here? Anybody think? I want one x all by itself. What do you think, Jocelyn? You bet, sister. I can factor out the x because it is the common factor. Log of 6 and log of 2 are 2 different values. Log is not common between them because log is not complete. It's half of a number. It's log of 6 and log of 2. Okay? Equals 3 times the log of 6. So that's the distributive property again. It's the factoring portion of the distributive property, but it's the distributive property. Now what would I do? So like if I had this, guys, negative 4x equals negative 18, how would I isolate I divide by -4. So to isolate this x, you know what I'm going to do? I'm going to divide by that and put it over there. So x is equal to 3 times the log of 6 divided by the log of 6 minus the log of 2. And I'm going to have to plug it into my calculator. That's the division property of equality. I divided both sides by that quantity. It says times, so I divide. And then I plug it into my calculator. So x is approximately equal to, you have to be careful when you're plugging those in your calculators. If you don't have that little yellow calculator that we use, you might have to put parentheses around your denominator so that you make sure that the top's being divided by the difference of the bottom. So I'm getting the answer 4.8928. So now we're going to check it to make sure it's correct, because you're not going to need me to know if you're right. You have the skills to check your work. So we'll plug that in. So that'll be 6 to the 4.8928 minus 3 should equal 2 to the 4.8928. And when you plug those into your calculator, you'll have to plug them in separately. And you can plug this in exactly how you write it. You don't have to simplify your exponent or anything. I'm going to press pause. So when we plug that in, we get 29.70877, which we would round to 8. And when we plug this one in over here, what do we get? 29.708. Is it 74? It's just a 4? So it's 8, 8, and 8, 4? Yes? Close enough. Double check it. I feel like, okay, last problem here. Actually, it's not the last one. I want to do one more on the back, but let's talk about this one. So here, my first question to you is, can I write 12 as a base 5? No, which means I can't use the common base. So, but something new. In our exponent is quadratic. That means there are how many solutions possible in this one for x? 2. So we do have to make note somewhere that this is going to give us 2 solutions most probably. Sometimes there's only one, but most of the time with a quadratic you get 2 answers. All right, so we can't use the common base. So we're going to use I'm going to use the natural log again because I'm feeling lazy. 5 to the x squared. I'm just going to take the natural log of both numbers because the property 8 says I can do that for logs. Okay. Then I'm going to power down so that I can get that x squared out of its lofty position down here with all the other numbers so that I can solve for it. You with me? That's property 7 that says the power of a log is equal to the power times the log. They're the same statement. And then how do I isolate this x squared? Divide by, what if it was 5x squared equals 12? What would you do? Right? Divide by 5? Right? And then take the square root? Right? That's exact plus minus square root, by the way. That's what we're going to do over here. So we're going to divide by the natural log of 5. So x squared equals the natural log of 12 divided by the natural log of 5. I just divided both sides by the natural log of 5, which is the division property of equality. Whatever I divide on the left, I divide on the right. And then I'm going to take the square root of both sides. So x is equal to positive or negative square root of natural log 12 divided by natural log 5. You know what that's called? The square root property. Okay, so now we just plug that into our calculator and we get x is approximately equal to positive or negative 1.2426. That last step we just call substitution because we're substituting the square root for its equivalent value. Now we're going to check it. So we're going to plug in 5 times a 1.2426 quantity squared, and we get 12 point, I don't remember, 0, 0, 0. I don't know if it's 1, 8. I can't, is it 1, 8? 1, 8. Close enough? It's supposed to equal 12. Yep, close enough. So it's good. Also, if I were to plug in the negative version of this answer, if I square a negative, isn't it just positive? Yeah, so it's the same. So we could say in solution set, am I been writing these answers in solution set? No. Oh, well, I meant to. So make sure you go back and do that. All right, so there you see enough to help you solve problems 5 through 14, but that will not help you solve problems 15 or 16. And they'll probably be the most challenging, so I'd like to do an example just so that you don't get stuck. Okay, so on the back side, real quick, I'll skip the whole proof thing and we'll just solve it really quickly. So let's say I have 9 to the x squared equals 11 to the x power. And I want you to solve that for x. It's a quadratic, yes? How many solutions possible? 2. I can see one right now. I could see that x equals 0 would actually work, because that would be 9 to the 0 equals 11 to the 0, which is 1 equals 1. So I can already see one of the answers just logically. But that's not the only answer. So let's see how we find the other one. So I can't make 11 a base 9. So I can't do that. So I'm going to use the natural log of both sides. Because if two numbers are equal, then the natural log of those two numbers is also equal. Then I'll power down using property 7. So x squared times the natural log of 9 equals x times the natural log of 11. That says the power of a log equals the power times the log. And then I have to solve this equation. So let me ask you a question. If I had this equation and I wanted you to solve for x, it's quadratic, yes? And I can't take the square root of both of those because I have an x on this side. If I take the square root of that, then I'm going to end up with x to the half, and that's not helpful. So what would I do to solve this? I can't square root it. Is that what you want me to do? Subtract 11x from both sides, make it equal 0, and then factor out the common x, right? That's what we would do. Then you would set this equal to 0, and you would set that equal to 0, and you'd find both your solutions. We're going to do the same thing over here. We have x's on both sides of the equation. We need to have both of our x's on the same side. So I'm going to go ahead and subtract that. So we're going to say x squared times the natural log of 9 minus x times the natural log of 11 equals 0. It's just our skills for solving a quadratic. Okay? And then, just like our plan over here, we're going to factor it out so that we can get our x's to be to the first power. They both have a common factor of x, so that's going to be x times x natural log of 9 minus natural log of 11 equals 0. Just factoring out as much as I can. Now we have an x to the first power and x to the first power. We're in really good shape. Either this x has to equal 0, 0 times something equals 0, or this quantity here has to equal 0. X, some number times 0 equals 0. So we have two solutions. So either x equals 0 or x times the natural log of 9 minus the natural log of 11 equals 0. I'm going to come over here to finish this problem out. So I'm going to go ahead and box that because I'm done with it. Then I'm going to finish this problem up here. So just rewrite it real quick. What would I do to isolate the x here? I would add this to the other side, right? So x times the natural log of 9 equals the natural log of 11, positive, because I'm adding it. And then divide, you got it, divide by the natural log of 9. so that I can move that to the other side. So we'll move that over through division. And then we'll plug it into the calculator and we'll get our second value. This one will be, I think it's 0913. Check me. Yes. Okay. And so then, of course, you would plug it in and you would check your answer. But at this point, you have that skill already. So that will help you with the last couple problems of your assignment. Okay.